We are live! Welcome everybody to another live stream. Today, as we have been doing this past week, we're going to work on psfc fun crisps in Godot. We're going to see Auralis Godot. Today we're working on the cameras, the different renders for the animatronics, and that means we're going to be going in Blender as well as Godot. We're going to implement all of these different renders, and it's going to be amazing. And as of course as it always tends to be, it always tends to be amazing. So we're gonna go in. We're gonna crush it. We're gonna do great. Alright. Nobody's tuning in, I don't think. I'm gonna pop out the chat so you can have the chat as a separate window. Yes. We're gonna quickly figure out the chat here. There we go. The chat has been figured out nicely. Now we jump into working on fun crisps. Fuck, I didn't do the GitHub file last stream. We're gonna do it now. I mean, I don't think that person needs it anymore, so it's fine. That was 2 streams ago now. Okay. Well. I would like to turn the blinds out so I can see a damn thing in here, so we're gonna do that. Let's turn out the blinds. We are creatures of the night in here, guys. Cannot allow the sun to shine through. We just can't. We cannot allow the sun to shine through. Anyways, so let's get this stream going. Where are we doing things? So let's run this again, see how it feels. They might tweak it. So I don't like this camera button one. It's way too dark compared to everything else. I think we're gonna make it brighter. This guy here, the camera hover. This camera UI layer is layer 5. Where's the vignette and aberration? Also layer 6. Okay, so I'm gonna move this to layer 6, layer 7. UI starts on layer 5. There we go. That looks fine. No, I don't like this. Layer 5. Yes, like that. Layer 6. Shit. This camera UI goes on layer 5. Yes, I want it like that. However, I want the camera hover to be on a new layer. So we're gonna have canvas layer, camera hover. Okay, this guy's gonna be on layer 2, layer 6, layer 7. Okay, and where we have camera hover in our code, let's open that up. camera hover area. I think it's fine. I think it's fine. I think it's gonna work. Okay. Yes. Perfect. Okay. So today we're going to be doing different renders for the animatronics. We're going to be doing different for cat, for pounding a shell. No, I think we're only going to have cat in this game. Only cat. At the very least right now. We might actually enable support for pounding a shell, however. Or no, we wanted the funhouse crew only. Yeah. So cat, we're gonna copy this. I also remove this to the collection. Cat. Yeah, we're gonna save this. Yeah. And then we're gonna copy this collection. Everything in this collection, like that, yeah. So copy this. And we're going to open the psfc3 map. psfc3 warehouse map. I think it's called warehouse in here, or warehouse thingy 2. Yeah. Okay, office, we're gonna go to all these cameras. We're gonna set the scale. Actually, I'm gonna talk less so I can work faster. Showing you assets of psfc4. You're not gonna see this. Nobody's tuning into the live stream. It's fine. We don't have it, man. What the fuck? What the fuck are these? We have one concurrent viewer. Hello to whoever isn't here. This is camera 2. No viewers, okay. Doing all this shit for an info project for fucking class. This is the most award for a fucking A ever. I'm gonna get an A. Clearly, I'm probably gonna complain I didn't use C++ enough. It's also a very high possibility, you know. She might very much complain. The teacher, I mean. Oh well. I like doing this though, so I'm gonna do it. I could spend my time better. I could have like 3 cameras, not worry about so much shit. Yeah, let's have those cameras. This camera map in like 3. I don't want to sit here forever. I mean, it would make sense for me to have a more complex camera. I mean, it's not gonna take that long to do this relative to how long it would take me to do it otherwise. So having more renders won't really do anything. It'll take me a bit more time to do now. I'll save probably like half an hour, which isn't much. I'm not sure. I'm putting in way too much effort for this. It shouldn't be. It doesn't take this much fucking effort to do. So okay, do I end up doing renders for these cameras? I mean, if the animatronic spawns in here, it's all these weird edge cases I'll have to do, but I don't need to do that. I need to put in the bare minimum, so I don't think I'm gonna have a render for this camera. I don't think that's worth it. Nor will I have a render for these cameras. Yeah, these 2 cameras we're not gonna have a render. And we're only gonna have a render for all the other cameras. So that's fine. So cameras like 11, 10, 9 don't have renders. Only cameras 1, 2, 3, 4, 5, 6, 7, 8, and 11. No, 10 and 9, whatever. There's 11 and all the others will. Okay. Yes. Okay, I'm trying to think here. So, what do I need? Do I want to spend so much time working on this shit? Like, I already did the bulk of it. I think I should just work on the asset. Like, 1 animatronic. Today we're gonna be done. If we get the AI working in C++. Today we're gonna be done if we get it in C++. So, we just want like an algorithm that returns like. Okay, wait. Wait, so my problem here is I know we have to do night 2. Okay, it's not gonna be so long. I have to do like a main menu. So I'm gonna sell out short on that. So okay. So let me think about this. So what am I gonna do here? Am I gonna have a cat animatronic? Yes. That's not even the question I want to ask. Do I want to have an animatronic? Do I want to render all of these cameras, bro? Like, do I want all these cameras? Can I not just make it simpler? I probably can. I can remove cameras 9 and 10. That'll take a bit more work, so I'm gonna leave it. Yeah. So we're not gonna remove the cameras. Yes, we're not gonna remove the cameras. Do you want, though, to have renders for each and all? No. So we're gonna render purely for cameras 1 through 8, and then 9 and 10 we're gonna leave out. Then we're gonna render 11, and then a jump scare, which I'm probably I'm gonna use the psfc 3 jump scare for cat. Yes. Okay, that's what we're gonna do. So rendering cam 4. He's kind of small in here though. Maybe bigger. No, having small because it would make sense compared to the elevator size. Yeah, it's good. Okay. Cam 4 render this. Whoa. Sure, it's a stream. So I'm having kind of an existential crisis right now. Like this was fun when I was a kid, but now it's not necessarily that fun. Like, I don't know, it's just more of the same. It's kind of boring. Like, it's cool enough so that it keeps me interested, but it doesn't light me up as much. I don't know if I want to do this anymore, you know? I don't think I want to do this anymore. I mean, I'll see like overall how I feel. I'll give it like a bit more time to see like the average way that I feel when I do this. See how it compares to everything. You know? I'm not sure if I want to do this for long term. It's kind of like dying out. I'm not gonna copy that pose. I really don't know, man. Oh, that's probably a no, because I don't really feel anything towards this anymore. It does feel, it's familiar. I know how to do it, right? But it doesn't feel good anymore, you know. I just do it because I do it because I want to do it. I do it because I've kind of bullshitted myself into thinking like, oh yeah, I'm doing this for the experience of it. I'm like, I don't think I want to do this anymore. Nothing. I'm not really excited about anything. Like, okay, the most exciting thing that I can do is probably like public speaking. But then again, what do I speak about? Like, I don't know. Like, I could probably speak about whatever, but it's like, I don't really know many themes to talk about. Like, I can talk about like letting go and personal development. I can work on. I can talk about that forever because I kind of went into that direction. But it's like, I don't know. I don't know which way. Like, it's hard for me to go back to this. I can't do it, and I'm sort of enjoying it, but it's like it feels kind of meh. Working for my dad, I think, is nicer. Like, I'm more thinking of how I could add value to the world rather than, you know, have a bunch of kids get addicted to a game. I can have him. I surely like doing this a little bit. I mean, do I like it? Do I like it if I don't feel much of it anymore? I can't do this for hours, you know? But it's not like I'm gonna continue doing this forever. Because I think it's running out. I feel kind of meh after this. I don't feel that fulfilled. So maybe it's time to stop. FNAF. Or I've said. said that I was gonna release psfc 3, so I might do that just as a last thing to do, because I've said it and I don't want to be incongruent, so that's that. But like, if I disappoint a bunch of people, what's it gonna matter, you know? It's not that big a deal, you know. I'm really not feeling FNAF anymore, you know. I'm really not feeling FNAF anymore. It's just kind of died out to me. I don't know though. It's kind of scary for me though, because I've not done anything else my entire life, and to like drop the one thing that I was good at, and I am still good at, and I could get better at, and expand to other domains from this. It's kind of scary for me to be like, you know what? I kind of want to drop this completely, because I was well and truly passionate about this, and it's not like I'm gonna it's not like it's gonna like completely fizzle out of me. I do still think about this from time to time, but it's like it doesn't feel the same. Yeah, that's kind of the best way I'll describe it. But then again, nothing feels the same for me anymore, because of that is whole part of inner work, and it's like my feelings aren't really attached to anything. It's just constant. I do have the hint of like old attachments that I had, like in Minecraft. I still kind of want to play Minecraft. That would be nice. But I don't really want to. I don't really want to make FNAF games anymore. I mean, to be fair, I could expand my horizons into something else and grow from that. That would be nice. I don't really like using computers anymore, you know? I do not like using computers anymore. So, okay, how do I solve this existential crisis that I'm having? I gotta find something else to do that I actually like. This guy looks dead inside, man. Look at this guy. He's dissociated completely. He looks dead. Look at his face. Well, looks like we're slowly gonna have to go back to the Dijkstra stuff. That's something. There we go. Okay. Okay, yeah. Yeah. Okay, let's see how Ket would look in this map. There we go. Okay, let's no. I'm still not sure what to do. So, but okay, I'll have to find something else. I'll have to find something else to do, and if I find something else to do and it fulfills me, then great. If not, then I'm fucked. To be fair, I still definitely do get excited to wake up in the day and do this. So I might not leave this completely. It's just the thought that I'm having, because like it's diminished. Okay, so cat there, 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 no cat here, no cat here, and cat there, yeah. Okay, now we need to modulate whether cat is there or not based on the cat AI, which we're gonna have to code in C++. We're gonna have to use the Dijkstra object. So we're gonna start Visual Studio 2022, or we could go back to Godot. We could go back to Godot, and we could do a number of things here. So we could go back to Godot. We could go back to Godot and finish the game apart from the AI, and then leave the AI for later. Okay, let's do that. Yes, we're gonna create like a mimicking class that is meant to, like in GD script. We're gonna create a GD script class about the AI, but then we're gonna replace it with a C++ class, because for the project, school project, you need to use C++. And I was thinking, you know what? Let's implement Dijkstra as the algorithm, cause why not? I mean, it's kind of dumb. It's kind of dumb, cause like you'd want to have multiple of these graph-based algorithms, but it's not necessarily. Yeah, you don't want to have all of these graph algorithms. What am I doing? It was a shit project to do, but I've started it now. I'm not gonna restart in like one day because I'm not gonna have time. I like doing this. Like, it's a nice way to spend my time. Like, it's a subtle enjoyment. Did I like it? Did I not like it, man? I'm not even sure. I didn't feel much of a satisfaction from it. I'm kind of already satisfied. I was like, yeah, a little bit more satisfaction. So then I did like it. Okay, so I'm gonna continue doing FNAF. Yes, this solves the external crisis. I'm gonna continue doing programming. I'm gonna continue doing FNAF, but there's other things that I can do, which I'm not gonna limit myself to, which I can include in my life as well. Yeah, simple as that. Okay. And I just gotta integrate everything. Yeah. I like the vent render. Vent render is nice. Look at this. It's nice. Okay, let's code the AI without the Dijkstra. Excuse me. Okay, so class animatronic AI. Now I'm gonna call this Dijkstra object. Yeah. Okay. We're gonna I think we call it graph object. Yeah. Okay, and then we're gonna function initialize. We're gonna take in a string. Adjacency matrix string. Okay. And then this adjacency matrix is going to be self adjacency matrix equals adjacency matrix. Yes. The function get adjacent nodes. Get adjacent nodes. Pass function. We kind of want the adjacent nodes, right? Yeah. We want Dijkstra. Node A, node A, node B. And then what? Do you want anything else? You want the adjacent nodes to get the adjacent nodes of the room. They want Dijkstra to create like a road between a node to another node, the shortest road. Yeah. 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 So, okay. We want that. Can we get it? Yes. Let's create this class in C++. We'll remove that. I don't think we need it. Okay. Okay. Well, shit me, this is hard. Okay, let's go through it. So, I have another implementation of Dijkstra. However, I'm not going to show that on stream. If I go in with my school account, there's an implementation of Dijkstra already there. Which means that I can probably use that. Probably have an easier time understanding that one because it's already done for me. It's already done in C++, I just have to implement it. But then I'm going with the easier way. And I said I want perfection. On perfection, I want. I'm short on time though. Yeah. Perfection will take too long. It's not even perfection here. It's just inconvenience. It's just like, it's. I'd be doing way much more. I'd be doing way much more for no reason. Just to get my brain working, which is a good enough reason, a good enough habit. However, I'm short on time. I think I'll make a new rule. So, if we're short on time, we go for the convenient way. If it doesn't take much time, we take the longer way. Yeah. Longer slash perfect way. Yeah. That's the rule now. Yeah. Okay. Let's see what Dijkstra's algorithm has to look like in this. So, let's. Okay, we have a Dijkstra algorithm. Okay. Let's take this. Okay. I'm not gonna show you this. Hold on. I'm gonna have this in here. Okay. So let me translate this code better. So we're gonna rename this to found min inf and max. Do we have anybody in the chat? Oh, Alden is Mick. Yeah, Alden is here. Hello. Yes, hi. I've woken up early as fuck, yeah. This is, it's 10 a.m. today. Right now, yes. Hello everybody, welcome to the stream. Yeah. Okay. I only just saw the messages. I had like an algorithm on my second monitor so I can so I can show it to you guys here. Okay, this is node count. I call it node count, right? Yeah, node count. Yes. Visited distance. Well, for me it's 1052. Visited equals int. Visited equals int. Like that. And distance. Rename this distance. Distance. Visited. Distance. Cost. Or rather adjacency matrix. Yes. Node count. And then previous nodes. Parent nodes. We'll call that parent nodes. Okay. Replace C with the adjacency matrix. And then create that adjacency matrix. Yeah. Okay. Okay. So this is the Dijkstra algorithm. We want to implement this in Godot. How are we going to do that? We're going to do that with a C++ GD extension. It's not the most optimal way, but I want an excuse to use C++ for a FNAF game and for school, so we're going to do that. It's kind of dumb, though. It's very dumb. It's very dumb to do this in C++. Don't do it in C++. Do it in GD script. I'm just an idiot right now, okay? This whole project shouldn't have existed. Like I could have like a better idea, but this was the first thought that I had, and I went with it. And yeah, this is what came out. I think the gameplay's pretty decent. If I go back in here, I can show you. The gameplay's pretty decent. I've created cat renders, by the way. This looks nice. There we can close the door. We still have to like have some renders where the animatronic runs to the door and jump scares us. But that it's very minute. So this is nice. This is nice. Also, we have no sounds. So I think we'll leave the sounds and like extra renders for tomorrow. But today we're working on the AI. We're 1 hour in. We're 1 hour in. I'm planning to do like a 3-hour live stream, so a 4-hour live stream. So we're gonna crack into that, anyways. So cat is rendered. We're gonna implement this Dijkstra algorithm. So I think I'm just gonna copy this because I know it works. I should probably test it though. Yeah. Let's have an adjacency matrix. Let's have an adjacency matrix where shit. Let's have an adjacency matrix where it mimics our entire map. Okay. Okay, so apparently you need to set this up differently. So int this adjacency matrix is interesting. Let me set up a graph. Okay, so what does the Dijkstra algorithm do? Does it give me a distance from a node to any other node? This is a different implementation that I saw from the this is a different implementation that I saw from Wikipedia. But no, it says it determines the minimum distance between a node and all the other nodes of the graph. Okay, so that means that if we have, we know what that means. It's kind of obvious what it says. So, I kind of want to get this done. You know. Yeah, don't wanna not speak as much to get things done faster. Yes, I will speak to kind of illustrate things as I move along, as I'm doing things, but I'm not gonna speak whilst I'm doing things. So let's get this code written. This is some of the stuff here. This is what I was just showing a bunch of code. Like, oh my god, code, yes. No, I mean, it's whatever. So yeah, I mean, no, it's pretty nice code. It's not that complex, but it's good. It's like a few state machines, a few functions, process functions, whatever. It's not too complicated. The real juice comes in now. It's like this isn't even like real juice. It's whatever. It's a very simple game, but it takes fucking a while to do. So we are, I believe, 11 hours in. No, 13 hours into the project. Yeah. So we did like a 2-hour live stream yesterday. We did a 4-hour live stream the day before. We did a 3-hour live stream, so that's already 9 hours, and then we did another 3-hour live stream previously. Fuck, how many live streams did we do? I think we did. Wait, it might be 14 hours. So 4 hours, 2 hours, 2 hours. So that's 6, 8, 9 hours now, and then we have another one that's 3 hours, I think. It's private. I think. We'll get back to this in a second. No, we did 2 4-hour live streams. So 4 hours, 4 hours. That's 8 hours, 10 hours, 12 hours. Yeah, we're 13. Yeah, we're 13 hours. Yeah, I was right the first time. Yeah, okay. Why was I talking about this? Fuck if I have an idea. That means that if we have, we know that it's kind of obvious what it says. So, just want to get that expression working. My mouth's getting lazy. Yeah, don't want to not speak as much to get things done faster. Yes. I will speak to process functions, whatever. It's not too complicated. The real juice comes in now. It's like this isn't even like real juice. It's whatever. It's a very simple game, but it takes fucking a while to do. So we are, I believe, 11 hours in. No, 13 hours into the project. Oh yeah, because I said okay. Because I said it's yeah, I said we are 13 hours in. Because it takes a while to do. That reminds me, I have not brushed my teeth. 1 second, guys. I'm gonna go brush my teeth. I'm back. I brought my cat over. Want to see meow? Want to see meow? Touch the microphone. He's biting me. You hear him? You hear him? You hear him? Touch the mic. See meow? See meow? Try to see meow? Kissing the cat. Kissing the cat. Meow. His breath stinks like shit. But I still love him. It is breaths, fucking cadavers of his breath stinks like shit. I brought my cat over. Want to see meow? Want to see meow? He's biting me. Yeah. See meow? See meow? Kissing the cat. Kissing the cat. Meow. His breath stinks like shit. But I still love him. It is breaths, fucking cadavers. So. Okay, my cat. I wanted to see how that sounded because I was curious how my cat would sound on stream. I'm gonna do some breathing exercises a second here. Okay, just some quick breathing exercises to get things going. Release some tension. Get me back to center. Okay. Alright, let's get back to this guy. Let's test this dice algorithm out. So we're gonna use the classroom, Google Classroom algorithm. Yes. I don't know what I'm feeling. What the hell? This is weird. Hello, Alden. This is fucked. Okay, well, let's set up the adjacency matrix. I'm doing the AI algorithm. It's called the Dijkstra algorithm. It's supposed to find the shortest distance from a given node to all other nodes. In this case, it's gonna find the shortest path from any camera to the office, basically. Yeah. Yeah. Useful for AI because like we don't want the animatronic to go into unnecessary cameras for no reason, you know. There's like a decent amount of cameras, so therefore we would want to calculate the shortest path to take. So, yeah. Okay. Adjacency matrix. Yep. Okay. This stuff I don't think belongs here. Okay, yeah, the distance, sure. But this guy does not belong here. This guy belongs in here. No, this... I mean, I suppose if you have this in here, it kind of belongs there. Does it? Let me think about this. So, if I have this guy in the main function, well, we're done with reading though now. So this all belongs to the main function. But it's still part of the setup. So we're gonna create a setup function. Void setup. And we're gonna copy this here. And we're gonna create the FN. Okay, we're gonna have a resource file called data.txt in which we're gonna have the map saved, as a adjacency matrix. So we're gonna have 11 cameras. And then we're gonna start from the camera. Oh shit! Fuck. 11 cameras. However, we want to include all of these rooms too. Albert. I have my cat here. He's gone. He's under a desk now. Wish I had a camera to show you guys, but that's for another time. I think I have a camera. Anyways. Okay. So set up adjacency matrix. Let's see. So 4 entire equals 0. I lower than that. I plus plus. It's fucking 1 based in here. Okay, I'll leave it 1 based. Just cause. No, no. I don't want to leave it 1 based. I want to make it 0 based. Let's make it 0 based. Cause it uses unnecessary RAM. I mean, probably the allocation in the end is going to be similar, if not the same. So I don't think it matters. However, yeah, okay, it doesn't matter. Fine. Fine. It's a lot easier to copy and paste. At school, we do 1 based code because we're cool like that. Usually, you'd have the best. No. We're gonna stick to best practices here. It's not gonna take much time to code this, so it's gonna be this is from 0 to n, or from 0 to the node count. 0 to node count. Yes. Set up cost matrix. Yeah. Sure. Okay, wait, so let's bring out like a paint thing. Let's bring the CS Academy graph editor in here as well. Okay. So we're gonna have a graph. Where can I find it? It's in here. We're gonna have this on my second monitor. So it's, actually no, we're gonna have to name these guys, these nodes first. So you are node 12. You are node. No, you're node 12. You're node 13. You're node 1, 2, 3. No, shit. 2, 3, 4. Fuck, 4, 5, 6, 7, 7, 8, 9, 10, 11. Okay, what this will look like, actually I'm gonna have this in split screen so you guys can see, is 1 is gonna be adjacent to 4. 4 is gonna be adjacent to 12, 4 is gonna be adjacent to 5. 5 is gonna be the 3, and 5 is gonna be the 6. 6 is gonna be the 2, 5. Yeah. It's undirected because it can go both ways. Yes, do we have anybody in the chat? No. 7 is going to be adjacent to 2, and 7 is going to be adjacent to 8. 8 is going to be adjacent to 3. 9 is going to be adjacent to 8. 10 is going to be adjacent to 9. 10 is going to be adjacent to 12. 12 is going to be adjacent to 13. Then 11 is going to be adjacent to 9. 11 is going to be adjacent to 13. 11 is going to be adjacent to 8. 11 is going to be adjacent to 7. Okay, so let's see how this looks like here. So 13 is down here. 12 is up here, right above it. 1, 4 goes like that. 10 goes in, goes to the left. This is gonna be a bitch. Hold on a second. Look at this shit. Okay, draw. So 10. 13, 12, 10, 9. Where's 8? 8, 7, 3, 2. 11 goes here. 6, 5, 4, 1. This is the map. This is kind of what it looks like. Okay. This is kind of what it looks like. And so we're gonna have a cost of 1 on all of these. Yes. What did it do? What the fuck? 1 does not correspond to 2. What do you mean? What did it do? It fucked it. I think I broke it. 0 next. I fucked it. Damn. Shit. Okay, let's do that again. 1 4 4 12 4 4 3 no 4 5. Okay, we're leaving in force mode, then we're gonna do it the same way. You're all paranoid. Whatever, so. Four, 5, 5, 6, 6, 2, 6, 3. No, 6, 2, 5, 3. Okay, so we got 1, 4, 12. 5 goes to 6. 2 goes like that. Like this. Yes. And 2 goes to 7. 2 goes to 7. 7 goes to 8. 3 goes to 8. 8 goes to 9. 9 goes to 10. 10 goes to 12. 12 goes to 13. Yes. Okay. So that's something. Let's change it back. So 10. Let's change it where it looks nice. Goes like that. Just draw these guys. So 13, 12, 4, 1, 5, 3, 8, 7, 2, 6, like this. Yes. And then you want 11 in here. 11 goes to 13. 11 goes to 10. 11 goes to 9. 11 goes to 8. 11 goes to 7. Yes. Draw. Okay. Something like this. This is what the map looks like in a graph view. So you can copy this by adding 1 to all of these. like that. Let's recalibrate it again. Okay, I'm not gonna bother recalibrating this again. Or no, I think no, I should because or before I'm gonna recalibrate it. 11 to 13, that is takes a cost of more. So 11, the camera's placed right before the office, right? I don't think that matters. I don't think that matters though. I don't think that matters. And what does matter though is the relationship between these. So these from these all go into 11, which is the same place. Okay, yeah, it's fine. Yeah, it's fine. It's fine the way it is. It's fine. Yeah. Okay, it goes like that. So it's not 11 nodes, 13 nodes. Starting node's 13. Yeah, yeah. Let's see. No, we need to set up first. This is setup. Setup. Right, we wanted to have a zero based, yeah. Yes. Yeah. Goes like that. Yeah. Yeah. Zero based. Like this. Yes. One second, I'll be back. Okay, we're back. Getting kind of worried based on the way I feel because I saw this. I'm like I'm kind of in my head, and I feel kind of disconnected from my body right now. So I feel kind of disconnected. I feel kind of weird, but I'm powering through. I don't think I should power through. Because I feel kind of disconnected because like, I'm in my head, and I'm like doing a lot of things fast, and I don't have time to feel what's going on. It's like the most pussy shit ever. But that's what I'm experiencing. Right now. But I mean, hey, it's just cortisol, so it'll pass. It's fine. Yeah. Okay. So let's keep going here. What's going on? So setup clearly hasn't worked for some reason. It's the distances are messed up. Oh, okay. Never mind. It's good. It's good. Okay, let's see what we're doing in this algorithm. Why is this distance vector messed up like that? It should have like a bunch of infinites too. Probably it's like a reading error, isn't it? I minus 1. J minus 1. Yeah. The fuck? Start node is 12. There we go. Now it's working properly. Let's see what it's gonna pop. What it's gonna spit out. -1, -1, 0. Okay. Because this is an undirected graph. I want it to be directed. Want it to be a undirected graph. Yes, 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 it works, it works, it works. Nice. Okay. So what about so okay, let me try this. So let me try to start node 1. Okay. 11. No, 10. What do we have here? So this is node 1, 2, 3, 4, 5, 6, 7. It picked that one because it has the least cost. Okay. Interesting. I don't see how this works though. Okay, okay, we're gonna create a new int. We're gonna create a new function here for Dijkstra path. We're not gonna read the start node and have the start node change. I need to take a piss, guys. Hold on a second. I'm back from taking the piss. Welcome everybody back. After I've taken the piss. Okay. So we're gonna create a Dijkstra path. So okay, 4. I don't even know. What do we do here? So I think we take the node the least distance. Whoa, what the fuck? It's all fucked now, huh? Okay. Start node. Start equals 11. Start node equals 10. Start node equals 10. Read. Let's read the start node. We don't need to do that, yeah. Okay. It's done good. Okay. Hello, Rockstar Games. How's it going? We are coding in C++ here, the Dijkstra algorithm. We're going to use this in Godot in a second. But I'm trying to figure out what is going on here exactly. My problem here is I cannot seem to identify how the hell this works. We would keep wanting to take the shortest node. Right? To where? I have a classroom assignment here. Okay. What does this code do though? What? Wait, sounds fucked. Sounds fucked. Something is fucked. Okay, he's good, yeah. And then now it's more fucked. Oh shit, okay, right. Okay. We don't want it int max. We want int max over 2. Yeah. Int max. Define int max over 2. Yeah, because it rolls over to the negative side, yeah. Whoops, that explains it. That's why I didn't understand before. I'm a failing student. I'm a piece of shit. Okay. I'm kidding. I mean, it's fun to say that, you know? So I keep saying it. Ah, interesting. What do we have now? Okay, so how did I create a Dijkstra path? How will I implement this? Okay. I'll create like a GD extension plugin for Godot. I'll have like a Dijkstra object, like a graph object. That's how I'll do it. I wasn't reading the chat, sorry. Okay. Okay, wait. So start node is that. End node is that. Yes. We want to get to end node. We want to get end node. End node is 13. 13 is end node. 13. We want to get to end node, which is 13. Yes. How will we get to end node 13? Well, let's look at the distances once again. We have we want to see if you want to always take the minimum distance from node 13. Wait, I think I know how to do this. So we have node 13 nodes. This is the graph. Okay, so start node. Let's set the start node to 2 8. Start node is 8, end node is 13. Let's see. Okay, so 13. The fuck, man. So wait, we want to go. We'd want to go until the distance to. So we want to go to 13. How do we do that? Am I smart enough to figure this out? Yeah, I've done it before. Come on. Okay, so let's do it. So start node is 8. End node is 13. Okay, we're gonna do Dijkstra path. And then we're gonna see out a different thing in Dijkstra path. We're gonna show a different thing in Dijkstra path. We want this though. So start node equals while start node different than end node. Yes, this is the condition. There's always gonna be a way. We're gonna see though how it's gonna be, how we're gonna check to see, how we're gonna check to see if we have, actually reached an end. Let's see here. So I'm gulping. Okay, so while start node different than end node. We want to set up. Start node is the shortest. We're going for a very crude version of the code. We're gonna create like a better version of the code in a second, which is gonna be tailored to the final game. However, we're working on this. Oh my god, it's been an hour already. We have 2 hours left of the live stream. I think we're gonna get the AI code done at the very least. So for int I equals 0, I lower than visited I visited I lower than node count I plus plus visited I equals 0. Reset visited. Start node equals 9, end node equals 13. Okay. Let's do start node different than end node. Yes. We reset the visited, we go setup, we go Dijkstra. Okay, setup changes the start node. Yeah. Okay. And then after that, we're gonna do this. So okay, we're gonna call it Dijkstra path. We're gonna call it Dijkstra path now. What do we have? So we have all the distances. We want to get to node 13. We check all of the neighboring nodes of the minimum distance node. Yes. Yes, yes, yes. We check all the neighboring nodes of the minimum distance node. Then, then we see if they're adjacent to 13. Then we see if they have a distance to 13 that is minimal. We go for that. So, yeah, we check all the neighboring nodes the minimum distance. We see if their distance to 13 is the minimal distance. Then we check the next neighboring, then we check the next nodes, neighbors that have no. We just check the minimum distance. We just check the minimum distance nodes to see if each one of them has the distance closest to 13. I think that's how you do it. Let's see. I could be a complete fool, but I think it makes sense. You take, let me find like a paint thing to better explain this. So we get the nodes. So we have, as we had there, if I show this again, So we are on node node 9, node 8, node 10. We want to get to node 13. Okay. And we have this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And this is our 3, 3, 3, 2, 3, 4, 2, 2, 1, 0, 1, 1, 2. Node 10 to node 13. We want to check now if we want to try out this node, and this node. And then we see which one of these has the minimal distance to 13. And then we repeat this same process again. Okay. Yes. Nice. So minimum distance equals int max. Oh, let's use inf for consistency. Yeah. Int minimum distance is infinite. Yeah. Okay. So minimum distance equals if distance I lower than minimum distance. Minimum distance equals distance I. Yes. Okay, so for int I equals 0. It's basically we're checking to see if we're getting closer to 13 or further away from 13, and we're gonna choose the path that gets us closer to 13 each time, or like the end to the end camera, the end node. Yes, that's how you do it. That's how you do it. I think I remember that's how I did it in psfc 3. I was working on psfc 3 and I did this in the second phase of the game that I'm not going to release yet. But that's how I did it. Okay. Okay, if the distance is the minimum distance, then we try again. Start node equals bool getting closer equals false. Int getting closer node. And node that gets closer equals -1. Okay. Now you check to see reset, visited, setup, Dijkstra. Start node equals node that equals I. Then we do Dijkstra again. Then we check to see minimum distance first. And minimum distance getting closer equals infinite, and then we go again for and j equals 0, j lower than node count. This is shit code that I'm writing here. Let's write functions with this. Yeah. This should all be one thing, so void void get minimum distance, then do that. Like that. Yes. This is janky as fuck, man. Okay, I want to try better here. So, how am I gonna return this better? So, we'd want int size. No. Int pointer distance vector, like that. Int pointer distance vector equals new int node count. Yes. Yeah. This is gonna be a bitch to convert in Godot and to see like if it works. Holy fuck. But challenge accepted. I'll get it working in C++ fully. I'll find like I'll interface this code with Godot because there's no way in fuck I'm gonna get Godot to recognize these types. There's no way in absolute fuck if I do that. That I do that. And I'm short on time too. Yeah. I mean, fuck. I could have this code be as janktastic as possible, but I think we want to keep it relatively clean, especially if it doesn't take a lot of time to actually have it clean. So we're gonna do that instead. Okay. Okay, so for int I equals 0, I lower than node count, I plus plus. We also want distance vector I to be distance I, like that, yeah. We're obviously going to be working with like different parameters instead. We're not going to have global variables. We're going to work a bit differently. We're going to have to restructure this code a bit differently so that we don't work with global variables, so that we can slot it into classes. And then we'll just fine on it. Yeah. Then wait, can you do this? Pointer reference in C++. Yes. Yeah, that should do it. Yeah. Okay. Okay, there's people in the chat probably. No, never mind. Okay. So this is the minimum distance. Okay, so in minimum distance equals int infinite int distance in pointer distance of vector. Let's have this on the same row for good code practices. Yeah. Nice. And now 1 second. Okay, we're back. Okay. Distance is minimum distance. First of all, distance vector. No. We want to call get minimum distance here. Right in here. Minimum distance vector. Okay. Distance vector for yes, like that. Okay, so now for int j equals 0, j lower than node count j plus plus. We want a new we want the minimum distance from test node. Yes. Which is get minimum distance and minimum distance test node distance vector. Yes. Yeah. And then for nj equals 0, j lower than no count j plus plus, we want to check to see if shit. Minimum distance, minimum. What the fuck am I doing? Whoa, 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 whoa. I'm retarded, I'm retarded, I'm retarded, I'm retarded. I'm retarded. What the fuck am I doing? 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 So hold on, hold the fucking phone. Hold the fucking phone. So how does this work? Hold on. So I just had a new idea here that said that, okay, this minimum distance is always going to be 1. Okay, it's not always going to be 1, but it's always going to be like, yeah, okay, to be fair, the test is to see if we're getting closer, so it's fine, it's fine. So, okay. Whew, I freaked out because I'm really retarded. Okay, alright. Alright. So, it's technically still good. However, we want... No, you know what I'm gonna do? I'm gonna bring these back. I'm gonna bring these back into the while loop. And... No, because no, I'm not, because I need to test to see if we are getting closer, and only then we're going to switch out our starting node. Yes. Sure. Yeah. So starting node. Start node. This is jankiest shit ever. Let's change it out now. Let's stop using global variables. Fine, no. We're gonna adapt the code later. I don't think it matters. Yeah. Holy shiters. Okay. Alright. So. Minimum distance vector. Okay. Test in start node equals test equals I. This is not the best. However, we're going to change it out in a second to have the best code possible. We're going to do it. Okay, so get minimum distance this vector should work because it's doing the dice thing. Okay. So it's going to go to... Okay, then we need to loop over this again. So for int j, int j equals 0, j lower than node count, j plus plus. Fuck, then I'd have to do this infinitely. Shit. Wait. Fuck. Okay, I'm gonna have to do something else. So. While getting closer equals false. For fuck's sake. So what it has to do, it has to go all the way to the end of a node to see if taking the shortest route of one branch is gonna take it to the end. And if it doesn't take it to the end, it has to take the branch that has the shortest distance. So that's a bitch. Fuck. Fucking fuck. How did I do that in psfc 3? How to compare the code? What the fuck? Man, I'm tired. Okay. Whatever, I'm tired. I can keep going. Look at this. So, we're pulling out the psfc 3 code, which is in Lua. For fuck's sake. So, what it has to do, it has to go all the way to the end of a node to see if taking the shortest route of one branch is gonna take it to the end. And if it doesn't take it to the end, it has to take the branch that has the shortest distance. So that's a bitch. Fuck. Wait, I know a way that I can make this work better. I know a way that I can make this work better. So, if whenever we add one to the distance, we might not have to do this like this. Fuck, we're gonna have to restore that. I'm gonna copy this, save it somewhere else. Okay. I'm gonna undo everything until we have the thing at the bottom. I've fucked up a lot. Oh, you know what? Okay, no, I fucked a lot of things. Let's get back. Let's copy the entire code and let's paste it again after we're done. Okay. This is what we have. Okay. I'm gonna take this. I'll paste it in here. Okay. That's the code, alright? Now. We're gonna delete this. Then we're gonna do the whole Dijkstra thing again. Dijkstra. Then I'm gonna do for int I equals 1, I equals 0, I lower than note count I plus plus. I think I'm gonna go back to the stream and rewind it. Coding's a bitch, man. Fucking fuck. First of all, did you check? Okay. Got the stream back. For if distance I different than infinite. Oh no, I'm gonna shut up. Code this quicker. Okay, works. Now, from this, I want to see if in the Dijkstra instead we can have the paths. This here, yes. We're gonna create a new structure here. Okay, so if not, I can use a matrix. Let's use a matrix. Let's use a matrix. That's the default type. Okay, so let's have a distance matrix in distance matrix 100 by 100. I don't think we're gonna have. This is a corner I'm willing to cut. Although we could probably dynamically allocate these. Yeah, we should probably dynamically allocate these, just so we have the code perfect. Yeah. Yeah. Nice. Okay. Anybody in the chat? No. Okay. Man, my neck's getting tight. My neck is getting tight. Oh my god. My neck is getting tight. 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 It's getting tight. It's getting tight. It's getting tight. Let's stretch it. There was a double chin stretch that really helped the neck tightness. And I think that's true. Give yourselves a double chin if you have trouble sitting. Now back to slouch position. You know what? We're going to do this stream standing up. I have a standing desk. We're going to stand up and do the live stream instead. Watch those engines rev. That's right, baby. No more sitting problems. We're standing up now. I'm even gonna raise my monitor. Yeah. Okay. Okay. So let's do this now. So Dijkstra, node count, blah, 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 whatever. So in here, we want a distance matrix. The distance matrix is going to be is going to have all the paths towards the current node. The node that we're trying to target. And all we need to do is we need to get the last path. Because that's the shortest path. I think. Right? It says so here. I'm not sure if it gets the shortest path. It visits a K node. Okay, so it's already visiting the shortest node. It's already visiting the shortest node, and it visits the K node. It visits the K node, then it checks all the nodes, and it checks to see if visited I which one's I? Oh. It checks to see if visited I is 0. Okay. Oh, so it only visits it when it interesting. Interesting how this works. I think this is the minimum. I like this algorithm already. So okay, so it's only visiting it when it finds a minimum distance node. Yes. Yeah. And then what? So it only visits it when it finds a minimum distance node. What else does it do? Then it goes and visits that node. Then it checks to see all the other nodes if they're visited and the distance. It checks to see if the distance between k, if the distance from k, if the distance from the starting node to k is 0, it checks to see if the distance from the starting node to k plus adding in this node is lower than the distance to the node. Yeah, so it's trying to get closer with each node. Yeah. So it already contains the path that we need to get closer to the final node. So then all we need to do is have the path matrix, and we're done. And then we can port this to Godot, and then we're off the fucking races with the AI and the C++ and the project's getting done, and it's all fucking good. Okay, all right. Okay, nice. Anybody watching this? Maybe not. Maybe not. Okay. Right. Fuck yeah. Let's do this. So, distance matrix. We only care about the distance matrix. Distance matrix. K Okay, we want a distance matrix and we want a length matrix as well. So int distance matrix lengths 100, like that. Distance matrix K distance matrix lengths K equals I. Yes. Let's call this the path matrix. And then path matrix lengths I plus plus, yeah. Like that, yeah. Let's see. Now instead of that, we're gonna show each and every one of the each and every one of the lines of the path matrix. So for int I equals 0, I lower than path matrix, I lower than k, I lower than node count, I plus plus. For int j equals 0, j lower than path matrix lengths I plus plus, j plus plus. Std cout path path matrix j ij, and then new line, and then std cout nothing. Let's see. Interesting. So that is a very peculiar. That's something. What the fuck? What the actual shit? Huh. Shit. $11 and 3. What? What do you mean 11 and 3? Oh no, 10, 12. Yeah, 10, 12. Yeah, that's fine. That's peculiar. What? Wait, what? Start node is 9. Huh. Interesting. Well, I wanna have the other display too. I have no idea what this thing's showing me here, so. For int I equals 0, I lower the node count I plus plus. If distance I lower than infinite std cout distance I, like that, else std cout -1. And then a space, and then std cout new line. And then in here, bitch, we want to show that as well. So let's see. What the fuck? I don't get it. What is that? Let's go through 6 now too. What the fuck? Ten, 6, 12. Way to go, 10, 6, 12. Before we only went 10, 12. What? Okay, this is gonna be a long one, folks. This is a long stream. Oops, not this. Well, I have an hour to go. I don't think we're gonna finish because this is fucked. Maybe not. So okay, what is it? What does it say? It's 2 nodes away from 13. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So wait, no, 1, 2, 3, 4, 5, 6, 4, 3. What the fuck? 0, okay, node 0 doesn't have shit. I realized, fuck. Did I not update the read? I did. The fuck? Did I mess up the data? I don't think I messed up the data. Okay, folks, we'll be right back. I'm kind of losing it here. I'm gonna take a break, and I'm gonna come back. And we're back. Okay. Let's see what the actual fuck is going on in this Dijkstra thing. Did I fuck up the data? 62566. Excuse me. Okay. Let's look through the algorithm now, see how it runs. Yeah. Okay, so it's going to node 8. Path matrix 8. Eight goes to 7. What? Where is it trying to go, though? Where is it trying to go? So 4 is trying to determine the distance from 9 to... If I go in here, it's on this guy. It wants to go this guy to this guy. And then what? What? It's trying to get to I of... What? How is this working? It's trying to get to every other node, right? So if I go to I, visit I is 7 right now. Why is it 7? Because that's the distance plus the cost is minimum. We're starting from, okay, distance K. 1. Distance I. 2. Hold on a second. So K is 8. Distance K. Distance K is 1. Distance I. How much is distance I? Distance I is an infinite. Okay. Cost matrix. Cost matrix Ki is probably also infinite. No, it's not. No, it's not. No, it's not. Distance K is 1. What? It finds 2. It finds 2. So in order to go to node, I don't even know. What node? Distance I. Fuck. The paths represent the equivalent in distance of shit. Balls. Okay, hold on. The paths represent the equal of the distance. The path matrix represents the path version of the distance vector. So this should be I. And this should be fuck. This should be K? I don't know. Let's try. That makes sense. Let's try K. I'm turning my brain off because I want to eat food. Okay, let's try eating. Let's try to turn my brain on. So, how much is? Do we want it to be K or do we want it to be I? Yes, we want to start with K. Okay, let's see K. Let's see K. How is that going to turn out? I don't know what to make of this. Right? So let's see. So let's see. So let's take on the map. So we're starting on 9, which is 0, 1, 2, 3, 4, 5. This is 9. This is 7. No, this is 9. Okay, yeah. This is 9 right here. So we want to go to 13. Go through 10. Oh shit. Oh shit. Oh shit. Oh shit. This is not the actual map. It's not the actual map. So 11 is not adjacent to 11 is not adjacent to 10 at all. Okay. Nichuna. Okay, so it goes through 11 and 12. Is that right? It goes through 11, 12, yeah. To get to node 1, it goes to... The fuck? Huh, this is kind of weird. To get to node 1, to get to node 0, it goes to node 3. That's not accurate because it needs to go to node 12 as well. Interesting. That's dumb. Why? Four is next to 11? Four is next to 12? Yes. 4 is next to 5. 1 is next to 4. Four is next to... Yeah, I need to go through that, but it doesn't have 12. Why does this work? Oh my god. Oh. Okay, so it goes through... Let's compare this again. So to go through node, to get to node 1, it goes through 7. What do you mean? No, you don't. Damn it. I don't fucking get it. Why is it so fucked? Is this true? You just got 3 nodes, yeah? So 10, 12, 12, 4, 1, yeah. Dude, this is messed up. Oh my god. Okay. Take another piece of cheese. So, the distance is accurate, but the path is not accurate at all. Let's see why. Let's see if we can change the paths. Maybe it's not even K. Let's add I. Doesn't do anything. But I don't think it's K either. What the fuck, man? Excuse me. Dude, what? The actual shit. I don't know. Maybe we can use the parent nodes vector. I'm not sure though. Let's see. So distance I becomes 2. I is 7. Distance to 7 is 2. Correct? Let's see. K, how much is K? What's K? Distance to 7 is 2 and it has to go through 8. We're talking about node 9, which is node 10. So we're starting from node 10. Yes. I is 7. Okay, no. I think I figured it out. So K. Then we also need to add I each time we do this. Could be wrong. 10, 12, 12, 8, 10, 10. Fuck. No. It's not what. But my logic was okay. We add I because we need to go. The target node is I. In order to get to I, we need this path. And that's already done by adding K. Yeah. Okay. So fair enough. Okay. So yeah. Okay. That makes sense. Yes. So these paths are kind of accurate, but they're not accurate. Why do we need to go through 3, but not through 12? Why is that a thing? Okay, right now, if I implement this in the game, the animatronics are going to teleport. I'm surprised we still have viewers because it's boring. I mean, I probably don't make it boring. However, the whole coding thing is boring. So I'm gonna stream for another half hour. gonna call it quits, I think, or maybe not, because I wanna get this done. I want to actually get somewhere with this. So, we're gonna work on this. So okay. So I is 7. So starting node. Oh shit. Maybe that's it. No, we'll see. We'll see. That's an idea. That's an idea. That's an idea. Okay. So we're in node 9. We go through 8 to get to 7. Path matrix of I is 8. Then what? Okay, I becomes 10. Let's follow the program, because I want to see the paths evolve. So I is 10. This guy. I is 10 is 11. What? Uh, 11 is not next to 10 directly, so why is it there? Okay, so we cannot use Dijkstra for paths, or at least in this implementation, because it's using the existing cost matrix to its advantage to create the paths, to create the distances, which means that it's creating new adjacencies where there previously weren't any adjacencies. Therefore, not all nodes are going to show up. Yeah. So how the fuck do we create a path? That's funny. Do you just keep taking the shortest path? I don't think that's going to work, because if we take the first shortest path, let's say we want to get from 8 to 13. Okay. So if we take the shortest path from 8, we end up in 7. From 7, we end up in 2. From 2, we end up in fucking 3. From 3, we end up in 5. From 5, we end up in 4. From 4, we end up in 1, and then we're stuck. That's not the way. That's not the way either. We want to see if we're getting closer with the road. We want to see if we're getting closer to 13. So, let's say we're 7. Okay. We try out going to 2. We try going to 2. Then we try going to 11. Then we try going to 8. Okay, going to 2. Is the distance from 2 to 13 any shorter than the distance between 7 to 13? If it's not, we don't go there. If it is, we go there, but it's not. Is the distance between 7 and 13 greater than the distance between 7 and 11 and 13? If so, we go through 11. Why am I programming in C++? Because this is a school project in C++, and I have to do it in C++. Yeah. It's quite dumb for Godot, I know. But I wanted an excuse to use C++. I wanted an excuse to make a game, so that's why. Probably dumb. I don't even. Okay, to be fair, it's kind of exciting. I like this. I like the ups and downs of it. It's nice. So, yeah. I wanted an excuse to make a game in C++. I wanted an excuse to make a game for school. Yeah. Okay. Okay. So as long as we're getting closer to 13, we want to do it. There's also the edge case of when we're not getting closer to 13. That's a bummer because this isn't going to happen in the game. However, we want to program it in because now that you know what, that's going to take too much fucking time. I'm just going to assume that we're always going to get closer to 13. So that's something. Okay. Yeah. So that's one thing. So if we're getting closer to 13, while we're getting closer to 13, we want to take the path that gets us closer to 13. Yes. Until we reach 13. So while 13 is now reached, this is the algorithm. And then write it in pseudocode in here. So while we're getting closer to the end, get closer to the end. If we're getting closer to the end, while end is not reached. Yes. Okay. Yes. Okay. So this is the algorithm. It's gonna be a fucking mess, but I think we can do it. Maybe we don't have to make it a mess. So, okay. I think this is prime time to start rewriting this with the way you said it, man. The way you said it. Fuck me, I just want to laugh. Okay. So why now it's prime time to get this code rewritten for better use in Godot. I have a lot of stream delay. Man, I don't know what's up with that. I mean, usually it's pretty good, but now it's kind of sucks. So, okay. I see the chat as soon as I see the chat. So, is what it is. Okay. Excuse me. So, let's rewrite the code without all these global variables. Okay. Okay, void Dijkstra. Okay, first of all, I think let's make this a class graph object. And then we're gonna have all these global, all x global variables. We're gonna have them stored as member variables, not the distance and shit. We're gonna have those as parameters. Okay, so or do we want to store them internally as well? Okay. So let's get this done. We're gonna rewrite the code, and then we're gonna have a piece of cheese. I have some cream cheese from President on this plate. It's ready to eat. It's like one piece. Dude, same. I haven't had like a game out since fucking 2022. And even then, I was working on it in 2021. In 2022, I was working barely on it. So I restarted now, basically. Yeah. Anyways. I mean, I like game rules as well. I got to 1,000 followers, and I kind of stopped doing anything. I made like models and shit. Nowadays, what I do is I just I post about games and I post about shit that I do on YouTube. You're an inferior human being. Well, all right. Making your account then. Dude, I think for motivation, the best thing to do is just clear your head. Clear your head of all the distractions, of all the bullshit. So that only what matters is what matters. Okay, so only what remains is what matters. Because then you're gonna be motivated all the time, because you're not gonna spend all this energy on this bullshit that you're not supposed to care about in the first place. And here you're gonna have to dive into things like trauma and why you're in the same patterns you're in all the time. And that's what I did, and I don't lose an ounce of motivation ever. I just don't. There's this guy on YouTube he's called Owen Cook. Look up his endless motivation guide. He probably has a video for you. Talks about limitations, talks about trauma, talks about talks about yeah, me too, I'm a perfectionist, but it's like you don't have to lower your standards. You can just have endless motivation. Like, think about this. You remove all the limiting shit in your brain that tells you, okay, I don't want to do this anymore, whatever. You know, that I don't feel like it, whatever. You can remove that from your brain. And then you always feel like it. You know, you always do everything you're supposed to do. But it takes a bit of work. It's not going to happen overnight. But you can get to that point. It also takes feeling comfortable in your own body. Not being able to sit for fucking minutes without distractions. I don't know where you're at in terms of like energy and the way you feel on a regular basis and like what runs you mentally. You're gonna have to study a lot of this because this is how you change at a fundamental level, and when you change at a fundamental level, everything clicks into place. If you like, I'm able to control what I want to do. Basically, like, what I did was I didn't want to do school before I now want to do school, because I'm calibrated to, okay, I need to do school, but I also want to do school because I enjoy doing school. But before I didn't enjoy doing school because I thought it was this heavy ass thing. But it doesn't have to be like this. You can train your brain to not think it's heavy. Sometimes it is heavy because sometimes it's just like, you know. Then I think it might not necessarily be that, because I have this guy Alden Remick. He seems to respond pretty quickly to what I say. Might be your internet. To what I say. Might be your internet. I'm replaying this back and it doesn't have that much delay because I have a direct playback of the stream on my second monitor. Yes, I saw the test now. Do you have the live checkbox there? Okay. Then I don't know what to tell you. But to me it's short. Nice, your Wi-Fi's back. Great. Okay. Whatever. Okay. Dice arguments visited distance. Excuse me. Okay. I'd have to end the stream. Hello, Lilithon. Dude. I mean, I could. But it's going to take me a bit of time. I think we're going to go... We're going to go do it after that coding this. Then I'm going to change the stream settings. If it's better for everybody. Let's do this. So, let's see. So, can you hear this now? Comment when you first hear this on the chat. So you saw it? How long did it take? It takes like a few fucking seconds. It took me like, I think it might have been like 30 seconds. So you saw it? How long did it take? To me, it's almost instantaneous. I know where to look, buddy, but I'm not gonna do it now. Okay? Like, I mean, I could. Yeah, okay, fine. I'm gonna end the stream and I'll start a new stream. Okay.